morning, children. Today's lesson we shall be starting with trends in M3 plus oblique M plus 2 standard electrode potential. What exactly does it mean? It simply means the E0 value for this combination will tell you how easy is it for the element to pass from plus 3 to plus 2 oxidation state. If the values are high, that means the oxidized state, this plus 2 state will be more stable. If the values are low, it means plus 3 oxidation state will be more stable. Let us study for it. Now you see the E0 value for scandium to pass from scandium plus 3 to plus 2 is very low, which indicates that scandium prefers to stay in plus 3 oxidation state as compared to plus 2 oxidation state. Reason being, in scandium plus 3, scandium is having D0 and S0 oxidation state, and thereby it leaves the nearest noble gas configuration completely filled for scandium. Similarly, if you look at the E0 value for zinc, to pass from zinc plus 3 to plus 2 state, we see that the value is quite high, which indicates zinc will prefer to stay in zinc plus 2 oxidation state rather than in plus 3. And why shall it be so? Because zinc in plus 2 oxidation state leaves behind completely filled d orbital, which is extra stable. But if you try to bring zinc into plus 3 oxidation state, it will disturb the symmetry and stability of completely filled d orbital, which is not preferred. Therefore, zinc plus 3 to plus 2 oxidation state is having high E0 value. Let us see this trend for a few more elements, like for manganese. The value is again quite high, which indicates manganese is more stable in plus 2 state rather than Mn plus 3 state. And the reason is, in manganese plus 2 oxidation state, D is exactly half filled, that is D5. Whereas in the case of iron, Fe plus 3 is more stable rather than Fe plus 2. Therefore, the E0 value for this change is low, which indicates iron is more stable in plus 3 state, leaving behind exactly half filled d orbital in the iron. Now let us look for vanadium. Vanadium has very low value for passing from vanadium plus 3 to vanadium plus 2 oxidation state, and this is because zinc, when it is in plus 2 oxidation state, it has half filled T2G level, right? So half filled orbitals or completely filled orbitals are always higher stability. Then children, we shall be studying the trends in higher oxidation states. Wherever we study the higher oxidation state, there is one statement which goes beyond any doubt, that higher oxidation state for any element will be observed either in the fluorides or in oxides. And why does it so? Because oxides and fluorides, they take advantage of very high electronegativity of oxygen and fluorine. Like to say, in the 3D series, we can see that manganese is the only element which can extend its oxidation state till plus 7 also. And here you see titanium plus 4 plus 3 plus 2, and vanadium plus 5 plus 4 plus 3 plus 2, and so is chromium, having largest number of oxidation state. It shows all oxidation states ranging from plus 2 to plus 6. And paying attention to all these things, you will see that highest oxidation state for any element is exhibited in its fluoride rather than chlorides and bromides. Fine, because fluorine is having the highest electronegativity value, so it is more capable to pull out electrons from the metals. Now children, After coming up from there, we shall be studying a few trends in case of copper. You see, if you have copper plus 2 ions and you take them in iodide solution, you will see that iodine is reduced to elemental iodine, whereas Cu2I2 is formed. So it indicates that iodine is a better reduce sorry iodide ions are better reducing agents than copper. This particular equation will remind you that iodides are better reducing agents than copper itself.